Ow! What the heck? Isn't it supposed to be an apple? Is this a potato? Why do you have a potato? Oh, hello there. I didn't see you. Welcome to Heather's Kind of Sciencey Show, where I teach you things that should be common knowledge at your age. Today we'll be talking about Newton's 3 laws of motion. Boom! Pow! Explosions. What? We don't have any movie effects? I'm just a 14-year-old who has no idea how to make a video? That's the point. Now, for Newton's first law of motion, which is personally my favorite. An object at rest will stay at rest. And an object in motion will stay in motion. Unless acted on by an outside force. Or a lake. Or, a simpler way to put it, an object that is still will stay still unless you push it. And an object that's moving will stay moving unless you stop it. Now, for Newton's second law, acceleration happens when force is pushing on a mass. The greater the mass, the greater force needed to push it. Or, a simpler way to put it, the heavier the mass, the harder it is to move it. Take this pencil, for example. It requires very little effort to move. Just nothing. But this gallon of milk over here will be a lot harder. I'm also just not strong. But the point is, the more it weighs, the harder it is to push. And this second law does have an equation. I know. Oh my god! Equations! I'm going to die! I promise, you'll be fine. But the equation is F equals ma, or force equals mass times acceleration. And I know what you're thinking. What could the unit for force be? Quite a fun answer. Actually, Newton has his own unit of force. Isn't that crazy? Maybe one day you'll have your own unit of force. No, not you, the person next to you. They're going places. And a really good example of force equals mass times acceleration is someone pushing their car. So let's say there's Terry, and his wife has made some really bomb meatloaf, and he's really hungry after work. So he's speeding down the highway to get there, and his car breaks down. No biggie, he's only 5 miles away from his house, so he just decides to push it. The car weighs 1,000 kilograms, and he's pushing it at 0.05 meters per second squared. Now all you have to do is multiply. You really don't have to worry about these units, kilograms, meters per second. It's all crazy. It's fine. So the amount of force he is pushing his car is 50 newtons. A good point. In these kind of problems, you won't have to worry about calculating acceleration. There's no need for that acceleration equation anymore. No, you're not welcome here. Now back to the fun stuff. No more of that math business. Newton's third and final law of motion is every action has an equal and opposite reaction. There are many ways of explaining and showing this. My favorite is most likely the push-up and the balloon, but we don't have any balloons, sadly. But we're going to need a helper. Oh, hi, Ethan.
What am I doing here?
We need you for science.
Why?
We need you to do a push-up.
What? No.
Yes.
No.
Yes.
No.
We need you to do it for science.
Fine.
All right, thank you. Now you see, when he's doing a push-up, he's pushing against the ground, moving his body up into the air. Equal and opposite reaction.
Can I go now?
Yes, this is my show. That's all, folks. I got hit with a potato, threw a few things in the lake, and made my brother exercise. This was a horrible mistake.
What are you doing?
Nothing. I think I broke my phone. Potato, 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 potato.
Heather, I don't think we should use the potato.
Why not?
They're not 6-year-olds.
But everyone loves Mr. Potato. It's so hot out here. I'm going to die. Or, a simpler way to put it, if an object is still, it'll stay still until you push it. But an object that's moving... Mom, you need to tell me that you're doing...
Still doing that. Oh, never mind. All right.
You through so much. It's time to end your life. Eden, can you give me a knife?
You're with El Shankar.